Excuse me, sir.
Yeah, tell me, ma.
What about the recordings of the classes, sir? Will it be available to us?
Yeah, it is there, ma. If you want, I will share it. No problem.
Can you please share the videos, sir?
You can able to download also. I think I am given one channel. No, you received one mail. The
Yes, sir.
channel name is Machine Learning and Applications. There you can download. For you also, it is available.
Okay, sir. Thank you, sir.
In Teams, you go to that channel and it is already recorded in that.
Yes, sir. Before it used to seen on the app also, sir, in the chat box,
Hmm.
but it is not showing now, sir.
I think they may. It is there. You can check it once. If not, you ask me. I will share.
Okay, sir. Thank you, sir.
But I will share the PPT. No issue.
Okay, sir.
Then anybody will come, huh? Why this delay? Okay, anyhow, I will start now. Okay, good morning, all of you. Today we'll start the second unit. As per previous classes and all, we discussed the machine learning basics, or also called as introduction of machine learning. That we have seen all the types of classifications. Supervisor learning and supervisor learning all relevant, and also biasing and then cross validation, evaluation, testing. So all introduction portion we discussed. Now we'll see the second unit related to purely supervised learning. As per our classification, as we know that there is a mainly four classifications: supervised learning, unsupervised learning, and semi-supervised learning, and reinforcement learning. In that, we'll see the first classification as a supervised learning. It is comes under second unit. Then we have the topics in the supervised learning: introduction, then classification and regression. These are the major concept in this unit. One is a classification, another one is a regression. In a classification, again we have linear, classification and regression. In the regression, we have linear regression, then logistic regression. Again, we'll go for classification. We have naive Bayes classifier. Another one is a neighbor that we in general we call it as a KNN algorithm. Another one is a decision tree. Then support vector machine, then overfitting, and advantages and disadvantages. So this is the agenda in this presentation of the unit. In this, we'll go in detail because it is application orientation. We'll take it as a lot of application, real-time application, and also we'll able to solve the problem as well. It is completely comes under supervised learning algorithm. In supervised learning algorithm, we'll go for problems as well. That is in the linear regression, logistic regression. Similarly, in classification also we have some of the algorithms that Navi Bayes classifier and K nearest neighbor and decision trees, and then support vector machine. These are the some of the algorithms using some problems. So we'll take it as a problem and how to solve a problem. Here problem is nothing else. There is a data. Past data they will give. What we need to do is the question they will ask you. For example, something in the new data they may give, ask you to find the target, are also called as a what is your answer for that. If the combination of the data is like this, then what is your response? Like that for all the cases. In even support vector machines also we'll discuss in that. For each and every case, k-nearest neighbor case or decision tree case or support vector or any classification or regression side, we solve the lot more problems. The intention of that is in exam they may ask any of the problem to solve using these algorithms. That's why we need to familiar many more problems and you try to solve it by your own. And at this point, we'll discuss only how to solve the problems numerically. But once if we go for project and all, what we'll do is huge amount of data is available, thousands of instances, all these things and features may be there. And we need to write a Python program to get results. So that is your assignments and all. If you want, you can do that way. You take it as any of the problem and try to implement that problem using Python programming. That is your assignment one. Suppose in this supervised learning, you take a after completion of these methods, you take any of the problem and try to solve that problem using Python program and submit to me. That is your first assignment. So like that, it is easy for you to solve the project also. You can do it by using the subject. That is the reason we incorporated this subject in the curriculum. Because of this, you can able to go for as a data analytics and a huge area. It is a emerging area. Try to learn thoroughly and also can get that MATLAB program or you can say that Python programming as well, so that it is easy for you to solve programming part as well. Now we'll see the introduction. As I said, no, in this unit mainly deals with regression as well as the classification algorithms. These two are comes under the supervised learning algorithm. These both algorithms are used for the prediction in machine learning and work with the label data. So why I call it as a label data? As you are aware that in the introduction of the first unit, supervised learning algorithm itself as a labeled data. Because in a supervised learning algorithm, the input and the respective or corresponding output is labeled. So whatever inputs are passing and corresponding output also known to you for the training purpose. That is what the label data. So that is the reason we can able to predict the our machine learning and work with the labeled data sets. But the difference between both, the regression as well as the classification, different machine learning problems is there. The main difference in the regression and classification algorithms is that regression algorithms are used to predict continuous values. This also one important you must note down. The regression means that continuous values, like what is the house rent in that area, or what is your age, and like that. These are the continuous values. We call it as a the regression related one, and like a salary, age, etc. These are all the continuous values. We can see that regression, and this data will be as a continuous data. Whatever maybe the regression line will be there, we can able to find what is the value that we call it as a continuous one. And whereas other one, you can see the classification algorithms. This will be used to predict or classify the discrete values. Discrete in the sense it is yes or no, or true or false, male or female, or zero or ones, the mail is spam or not a spam. So like that, that will be call it as a classification. So categorized, you can say that. And class 1 and class 2 like that. So we can able to identify that using these. These are the major classification or difference between regression and classification. One broad way you can remember is The regression is nothing but a continuous values. You can able to predict your salary after 1 year or after 2 years or something, or we age or something different kind of values that will be as a directly as a continuous value. But whereas in the classification side, we can able to classify the total data into categorized. Let it be this group is related to as mangoes, the other this set of groups is related to apples, and something like we can able to clearly specify the category that we can say either the people are there in a class, these are all the females and these are the males or something like that, or whether your answer is true or false, or your response is either 0 or 1, like that. If a group of males, we trained the system, and once new mail comes, that will be segregated whether it is related to spam or it is not a spam. And if it is a spam, the new mail is go to spam box instead of inbox, like that. These are the major difference. Now you can see our supervised algorithm broadly classified the regression as well as the classification. So this is comes under a supervised algorithm. If you go for unsupervised like this, we have clustering and association like that. So that is another part in the next unit. Now, we can see in this supervised algorithm broadly classified as a regression as well as the classification. In that, you can see these are the some of the methods are available in the supervised learning algorithm. These methods we are going to discuss in our problem, I mean this unit, because in the syllabus I already mentioned linear regression, logistic regression, k-nearest neighbor, support vector machine, decision trees. I think this is not mentioned in a syllabus, but this is also comes under supervised learning algorithm only, because of the number of hours constraint, all these things. Some of the techniques I mentioned here, if you are aware these techniques, and then you can take any of the journal paper and you can able to solve how we can able to predict the new data, the response, if you can apply the random forest algorithm. This is also comes under. So like that, many more algorithms are there related to this. But what is our constraint is, as per our syllabus, we'll discuss the linear regression, logistic regression, and k-nearest neighbor, and support vector machines, and decision trees. These are all comes under supervised learning algorithms. Now we can see the regression as well as the classification introduction, and we'll move on to classification and different types of algorithms as well. In a regression algorithm are used if there is a relationship between the input variable and the output variable. So the relationship between input variable and output variable, this let assume that as a regression line. And if you know the relation between input and output, then we'll go for as a regression. So this is the major point. Whenever if we have a relation between input and output, then we'll go for as a regression. The prediction of continuous variable, I already mentioned, in a regression deals with the continuous variable. It is able to predict continuous variables such as weather forecasting. It is also continuously varying. And then market trends are like, what is the scenario in the market, demat accounts, trading and all, that you can able to predict this data. And then popular regression algorithms are again the supervised classified as a regression. Another one is a classification. And in regression again, we can classify some more categories. This regression again, we can able to divide some of the categories like this. One is a linear regression, a regression tree, non-linear regression, Bayesian linear regression, polynomial regression. So like that, only the equation will differ. You can go for either linear regression or polynomial regression or non-linear regression. Like this, we will see examples of each of the method as well in the case of regression algorithms. And second one is a classification. These classifications are used when the output variable is categorically, which means there are two classes such as yes or no, or male or female, or true or false, like that. So this is the categorically, there are two classes. In this case, you can go for as a classification. Like example, one example, spam filtering. We can use this. This is our object. Let us assume that the new mail comes, whether the mail is related to spam or a not spam. In that, we can see categorically random forest is one algorithm we can use. Like I already mentioned, no, these are the some of the things. The regression algorithm, logistic regression is there, and then a decision tree you can use it, and random forest you can use it for the classification. So the decision tree, you can see that this group, we are keep on going yes or no, like that. It will comes to the end based on your starting point of that. So like that, you can go for as a decision tree classification, and logistic regression is there, and this support vector machine also used for classifications as well. So these are the some of the things. Now we'll go in detail of classification, and then we'll move on to regression. As per our syllabus, as I mentioned, only major topics are two. One is the classification, another one is a regression. In classification, we'll have some of the algorithms, and regression will go for some algorithms with problem. That is only the total unit. This classification is a process of finding a function which helps in dividing the data set into classes based on the different parameters. So now, based on the features, we can able to divide, and let it be this is x1 and x2 and so on. You may have x3 the data, and finally you have to classify your target. What may be with this data, whatever may be data you may have like this in the different features, and finally you have to categorize whether this is positive group or negative group, or positive group or negative, and so on. We have to divide only like this. So what is your objective or final task? You have to classify, if these features are there, then this is comes under positive, and these features are there, this is comes under negative, like that. We are keep on classifying only two classifications here. So one is either true or false, or 0 or 1, and yes or no, or category, only two. It has to decide like that. That is what we'll go for as a classification. In classification, computer program is trained on the training data set, and based on the training, it categorize the different classes. So here, program, we are not writing anything. The computer system is going, or you can say that model is going to be trained with the available data. Based on the available data, the model is going to be trained, and you can say that whether it is yes or no, or true or false, or something like that. For that, we have a lot of algorithms you can able to apply to classify this. Because in exam, the one data set they may give something like that, features are A, B, C, something, and then there is a target, and there's some data related to this. The target may be positive or negative or yes or no, whatever in the manner will go. This is the data set they may go. And in the new data set, the question they may ask you A, B, C, and data they may give, and target they may give question mark. What is your result? And A may be something, B may be something, C may be something, that feature based on that data, and you need to identify this data is a new data, which is not available in the test data, so that we can pick up something like that. It is not possible. Using the existing data, we have to train the model, and once new data comes, you use that model to predict what is your outcome. So that way we can able to categorize. The task of the classification algorithm is to find a mapping function to map the input X to the discrete output Y. So to find mapping function, so what is it? Input is X, correspondingly, what is your Y you have to find. In that example, best example is email spam detection. So what is email spam detection? New mail comes, what is the classification here? Whether it is a spam, not spam. So like that, we have to decide for classification. The model is trained on the basis of millions of emails on different parameters. So how the model will train? Because directly when small set of data, you cannot identify once new mail comes. So Google has to send whether this mail is related to inbox mail or is a spam mail. How it is known? Because of the huge training data is there. The model is already trained. Using that, we can able to find the response. And whenever it receives a new mail, it identify whether the mail is spam or not. How to identify? The model is going to identify. How the model will build? Using a classification algorithm, any of the algorithm. And the model is going to train from the data set. And these are the combination of features. Then the mail may be spam or mail may be not spam, like that. You have to give the data for training purpose. And after that, once new mail comes, the model is ready to classify whether it is a spam or not a spam. So if it is a spam, then it is moved to the spam folder. And you can see another algorithms as well, types of machine learning classification. So far that is only the introduction. Now we'll see some of the types of classification algorithms. So we can divide further, because as I shown you in the last slide, we have a lot of algorithms in the supervised learning. In a supervised learning, again we have as a classification as well as regression. In a classification, what are the algorithms related to that? And again, after this, we'll move on to regression. What are the types of algorithms? Now, some algorithms will work for both classification as well as the regression. So now we can see here some of the classifications further dividing into logistic regression, then k nearest neighbor algorithm, and support vector machine, then Navi Bayes algorithm, and then decision tree classification. Another one is random forest classification. So these are the some of the algorithms in the machine learning. We can observe in the next course. We'll go for one by one algorithms. And now classification is a supervised machine learning algorithm method where the model is tries to predict correct label for a given input data. So what it will do, I shown you in the past, there may be features are something ABC, then this is a output. So what this model will do, so for A data and similarly B data and C data is available in your command window, or the data ABC, new data comes, they may give A is something, B is something, C is something, then what is your output? So final answer, they don't expect any value. What they will expect is any of the classification. So if these are the features are available, then probably your target is this much. So that way we can able to classify as well. Now, The model is trained on training data, evaluated and tested data, and used for prediction of a new data. This is the common sentence for all the cases. What we do is we have to train the model, then evaluate it based on our test data. After that, we can able to deploy it. So once the machine is ready, we can able to find new data. For instance, as I given in the previous example as well, given email is a spam or harm. So no spam like that, or we'll illustrate something like that. What is the model? Classification model is available here after giving something training and validate data, because lot of data is available in a database, and if I pass this data, we are giving as a labeled as well in the output side, it will maybe spam, or if we pass this data, maybe not spam, or something against spam or against spam, something like that. We are keep on giving the data set. Based on the data set, the model is able to predict what is your response. So in that case, what we did is classification is a supervised machine learning algorithm. Our model is try to predict a label for a given input data. After that, the model is trained on training data, evaluate on the test data. The used for once the test data is over, then we go for as a deployment. Now we can see what is happening here. The given data is, we are giving the training, then model is trained. After that, you are passing as a some incoming messages. That messages, if we simply pass, then automatically the model, you can see here the intelligent model or machine learning model will segregating two classes. I mentioned that classification yes or no or true or false, spam or not, or zero or one, only two categories. So that is going to be divide. This type of mails is related to as a spam mail, and this is related to as a inbox mail. So like that we can able to. So now what we'll do is understand the difference between two types of learners in classification. There is a one different, you can see that lazy and then eager learners. So in general, the lazy learner, there will be classify the misconception between classification and regression. So we'll see that lazy learner versus eager learners. Two types of learners in machine learning classification. One is lazy and then one is a eager learners. Eager learners are machine learning algorithms that first build model from the, this is what normally easiest way. But lazy learners also will see in each time we have to memorize that and will predict instantaneously without any model. But now there is a eager learners first build the model. So how the model is going to build? As you're aware that by giving as a training data set before making any prediction on further data set. So once if your model is trained, then we can able to build the model. So once the model is built, any prediction in future data set you can able to find. This the spend more time during training process, because if you are giving less data or insufficient data for training, then the prediction accuracy is going to be minimized. So that is the reason what we'll do is we can able to train the model perfectly with a lot of data. Then what we'll do is we can better generalization during the training from learning the weights, but they require less time to make a prediction. So this is the one aspect. For training, we are spending more time and more data set. Once that is happened, then the prediction is easy because model is very accurate. Model is going to develop. Then whenever the input data is given, in that case, it won't give more weightage to get the response. Means it will take less time to get as a response or prediction because model is very accurately designed with the help of the training data set. And most machine learning algorithms are eager learners. This is what we are following. Like these are the some of the algorithms we'll use for the eager algorithm because whenever the model is developed initially before prediction, then we call it as a eager learning algorithm. So logistic regression, SVM support vector machine, decision trees, and artificial neural network. These are all comes under eager learners. And lazy learners are instance based learners. So what is instant based learners? Do not create any model immediately from the training data. So whereas previous one, from the training data, model is going to be developed. But here, lazy learners or instance based learners, what we'll do is do not create any model immediately from the training data. And this will where the lazy aspects comes from. So because it is not model, then we can call it as a lazy. Memorize, what they will do is that will memorize the training data without developing as a model. Simply it will memorize the data, training data, and each time there is a need to make a prediction. So what it will do is it is time consuming process normally, but whereas in the eager learner, initially we will train and model will be created. After that, it is very less time to predict. But what is happening at every instant so as to memorize the data and then make the predictions. So the search for this nearest neighbor, this is the one of the algorithm is a very poor performance, the nearest neighbor from whole training data, and which makes them very slow doing expensive, which makes them very slow during the predictions. Whereas there, the eager learner predictions are very fast. These are the some of the examples, kind of what you call it as example for the lazy learners are K nearest neighbor and case-based reasoning. Mm, reasoning. These are the two algorithms that comes under lazy learners. And in that classification, by seeing this, no explanation is required. What we have is classification and then regression. So these are the two only. But in that, what we can do, it is comes under supervisor learning. After supervisor learning, target variables we have to divide. So once the target variable is divided, like A and B, continuous and categorical. Continuous means regression, and categorically, I mean, categorically means classification. These are the some examples. Now we'll see some machine learning classifications in a real life problem. Still, we are not going in detail of calculation part and all, but we are trying to understand what are the problems are available, classifications we can able to solve using this real-life problems. As we already discussed, classification has different applications in multiple domains, day-to-day life. One is healthcare. In this hospital, patients' data can help to healthcare specialist accurately can able to diagnose because like COVID-19 and all, we can easily predict. So multiple features are there: cough, something fever and headache, body pains, rashes. So by using these are the features and available data, because a lot of data is available by that time, we can able to uh, find whether we required the I mean, using the data, we can able to predict whether the particular person is having COVID or not. So like that, the healthcare system and also the eye diseases or cancer diseases and major things, we can able to using the machine learning algorithm, we can able to predict these features are available, whether the patient is having the COVID or let it be cancer or a disease or XYZ. So we can able to predict. That's what we can see that during COVID-19 pandemic, they were implemented the efficiently predict whether the person is had COVID or not. And then researchers can use machine learning models to predict new diseases that more likely emerge in the future. So that is one aspect. I'm telling the in real life where we are able to use this classification and all. So now another one is the education sector. In education sector, dealing with the most textual and video and audio data is available. The unstructured information can be because video data and then voice data and then text data. These are all unstructured data. Can be analyzed with the help of a neural language technique to perform different tasks. So you can see such as documents as per category, analysis, student feedback, semester about the faculty. And then third one will move on to transport. As we discussed here, the healthcare and education is example. And another example is the transportation also. To predict which geographical location will have a rise in a traffic volume. Because in the city, while you are traveling, will always require the routes traffic. So whether so and so area is having heavy traffic, then we are to divert instead of going that way, we'll move to some other direction to reach our destination. So for all this, even radio also will announce you so and so route is heavy traffic is jam, something like that. In that, we required as a prediction in traffic volume in the particular area. Now, potential issues that may occur in a specific locations due to weather conditions. And then sustainable agriculture. This also nowadays very huge data analytics is going on in the sustainable agriculture as well. This can help to improve farmers' productivity at a different levels without damaging environment. So what we can do is here the farmers is able to predict in advance the after 4 days the rain may comes or today rain may come or so and so. So if you can able to predict some data so that it is easy for us to get predictions in the later point of time. Now we can see by using classification model predict which type of land is suitable for given type of seed because data, the land testing also there, soil test and all. So we'll get the, if you do soil test in the many areas, we'll get the data based the what is the health condition of that soil and all. Based on that, which crop is suit for that area or in that land. So it is easy for us to predict and then whether the help them to take proper prevention measures or some cases nowadays IoT based sensors are also deploying the land and that will give the lot of information the raw data based on that we can able to use your water what we called as sending water to the plants, and whether tomorrow rain may come or not. Based on that, whether we have to give the water to plant or not, and how much water is required, what is the wet percentage in that, and or like that. And at some point of time, you may identify some, bacteria attack, all these things we can easily identify using the data. So these are all some important. Now different types of classification tasks we'll see. Mainly we have binary. I already classified there in the classification itself. We have binary classification, multi-class, multi-label, imbalance classification. These are all some of the different types of classifications in machine learning. We will see one by one, briefly one or 2 point. What is binary classification, multi-class, multi-label, and imbalanced classification. And binary classification goal is to classify the input data into two mutual exclusive categories. Mm, Goal is to classify input data into two mutual exclusive categories. Now we can see the example also. The training data in such a situation is labeled in a binary format, either because all classifications mentioned in a the category case, true or false, and positive, negative, 0, 1, spam or not. In that, what we'll do is, for instance, we might want to detect whether the given image is a truck or a boat. So this is a classification. If we pass the any of the image, that will give you classification, whether that will be classified as a truck or not. A truck or a boat, some images. Now we can see here, we will pass the boat and the machine learning will give the classification. It will be as a boat. Like that, the model is already trained because we trained the trucks and boats, different categories, and the machine is able to capture that image and it can able to identify whether it is a boat or a truck. And logistic regression and support vector machine algorithms are natively designed for binary classification. So in this type of classification, we'll see SVMs, support vector algorithms, and then logistic regressions and all will use to identify this type of classes. And such other algorithms also there, k-nearest neighbor, decision tree can also be used for binary classifications. So now we'll see some more multi-class classification. What is multi-class classification? You can see here the at least two mutual exclusive class labels where the goal is to predict whether class is a given input example belongs to. So now we'll plane or boat, truck, like that if we pass and we can easily identify in the following cases, the model correctly classified the image to be plane. So because we already trained that model by passing the different multi-class classifications, and it has to identify once the image is there, it is related to which classification. And most of the binary classification algorithms can be also used to multi-class classification. So we can able to use multi class classification using this method. Include or not limited to that, but there is some of the algorithms also there to do this. The random forest algorithm, Navi Bayes algorithm, k-nearest neighbor, support vector machine, logistic regression. So these are all the some of the methods. And what the question is, support vector machines and logistic regressions do not support multi-class classification by default. So, but sometimes it will not be do that way. But however, we can apply binary transformation approach such as 1 versus 1 and 1 versus all to adapt native binary classification algorithm for multi class classification task. So for this type of things, we can able to do this support vector machine and logic regression as well. Now we can see 1 versus 1. So what is doing is here, this strategy trains as many classifiers as there are pair of labels. So we can see first binary classification, we pass the one plain, and then second binary classification also the plain, and then third binary classification is a board, something like that. So 1 to 1 it will compare. So 1 versus 1. And in general, n labels, we have n into n minus 1 by 2 classifiers are there. So if you want to pass n label, then obviously n into our C classification, C into C minus 1 by 2 classifiers are there. Each classifier is trained on a single binary data set, and the final class is predicted by a majority votes between all the classifications. Now 1 to 1 will classify whether it is yes, it will give 1 vote. If no, it will not give. So like that will count, and who is having more majority, that kind of classification, that is the particular classifier is going to be. 1 to 1 approach is worst, is work best for support vector machines and kernel based algorithm as well. So later kernels approaches also will come in the later point of time. And 1 to 1 approach is work best for support vector machine, and 1 versus the rest. Now what it will do is it will compare this with this and so on, will give and so on so forth. If you have many number, we can able to identify the considering each label as an independent label and consider rest combined as only one label. So with 3 classes, we will have 3 classifiers. In general, n labels, we will have n binary classifications. So now another also there, multi-label classification. In this, we try to predict 0 or more classes for each input example. In this case, there is no mutual exclusive because the input example can have more than one label. Such a scenario can be observed in different domains, such as auto tagging in natural language process, and where the given text can contain the multiple topics. Similarly, computer vision image can contain multiple objects because one image may have multiple objects inside the image picture. As I will show that this is the multiple image. We can see that this is truck and boat or something, and it has to identify the correct one. So it is not possible to use multi-class or binary classification model to perform multi-label classification. But however, most algorithms used for this standard classification task have their specialized version for multi-label classification. We can see that multi-label decision tree you can use, multi-label gradient boosting you can use, multi-label random forest. So like this, some of the different types. And imbalanced classification, this is one of the example I mentioned there. In the imbalanced example also, number of examples is uneventually distributed in each class, meaning we can have more of one class than other in the training data set. So like you can see 60% trucks are there, and 24% place and 50% boats. So this is the problem normally. That's what I used to say many number of times. While you are giving training data set, must have mixing of all the types of data categorically. But what we are doing, imbalance classification is in the data. we are giving 60% of data showing trucks and 24% of the planes, and boats are 50% of combination. And once if you get the new data comes, the other feature of planes and boats may having less, that may not be predict accurately. So that is also one problem normally, but preferably you try to mix the data proportionately, and we can train the model. Let's consider this three classification scenario, what we are observing: 60% and 25% and 50%. And this imbalance classification problem could occur in the some cases. That is a fraudulent transaction detection. That is a fraud, what you call it as credit card transaction and all. A rare diseases diagnosis and customer analysis. These are the some of the imbalance problems could occur in the scenario, because the data may not have sufficient proportionate. That is what occur will this type of data imbalance will occur. Conventional predictive model such as decision tree, logistic regression, etc., could not be effective when dealing with the imbalance. So when this data is imbalance data, then what we'll do is we cannot use decision tree and logistic regression to identify the new prediction data. Now we'll see in the next class support vector machines one by one, classification and regression. Based on that, we can go forward. If you have any doubt, you can ask me. Otherwise, you can leave because other class is scheduled already. So next class, we'll see the support vector machines and all. It is also simple, but the thing is, it is very efficient method, support vector machine, and how to find, will solve the many problems in the support vector machine like that. So we'll go for one by one, whether support vector machine or decision tree or regression later point of time it will come. And many methods, what I discussed, broad method. That methods, I will explain the algorithm basics, introduction, then we'll proceed with the problems. Thank you. Now you can leave.